Mom. Welcome back to Learning Physics with me. Today, we're going to be learning about power. So far, we learned about velocity, momentum, force, and energy. Power is a cool concept because it's one of the most intuitive concepts that we'll learn in physics. Sometimes we mix up force and power. Now, you have to remember that force is what the object feels when you exert power. Power is what you feel. The net power transferred to or from an object is described as the rate of change of that object's kinetic energy. That is to say, delta kinetic energy over delta time. Another way we can find power is by multiplying the object's net force times that object's velocity. Force times velocity equals power. Sometimes there's more than one force acting on the system. For example, this week I will be squatting, I'll be doing a back squat. There's going to be two forces. There's going to be the force of me exerting up on the weight, but also the weight is being pulled down by gravity. That's another force that we're going to have to calculate. Now, to get the total force of that system, we're going to have to add those two forces together. Now let's go to the video. And with this video, we're going to find a couple of different forces and a couple of different powers. We're going to find the net force, that's the total force. We're going to find my force, and we're also going to find the total power and my power acting on the weight.
Now here's the video. Keep an eye on the graph to the right. That's velocity versus time. And that's an important graph when we are trying to figure out the forces and the power. I squat to the bottom and then back to the top, and then I cycle this a few times. We will use the graphs created by Tracker and compare them to my human experience of when I felt the most power being exerted.
Now, before we look at the graphs, let's take a look at the formulas that I had to put into Tracker for Tracker to put out these graphs that I want. So as we've seen before, Tracker will come up with some of these graphs that we like to see, like acceleration versus time or velocity versus time, but it doesn't come up with every graph that we want. So we'll have to go in and actually plug in our own formulas to see the graphs that we want to see. For this experiment, we want to see the force acting on the weight, the force of me, the power acting on the weight, and my power. These are the formulas that we're actually going to go in and plug in so we can see those graphs. To get the force acting on the weight, it's mass times acceleration like we've talked about before. And then we want to see the force of me, and we'll take that force of the weight and add it to the mass times that gravitational constant. Now, to get the power acting on the weight, we'll take the force acting on the weight and multiply it by the velocity. And finally, the whole experiment is trying to see the power that I feel. So the power of me will be the force of me multiplied by the velocity. A couple of things that to note are everything is happening in the y component, like the velocity in the y and acceleration in the y. That's because in the video I'm squatting and the weight is only moving in the y direction. Next week we'll talk about what happens when something is moving both in the x direction and the y direction. Those are called vectors, and we will talk more about that next week with projectile motion. Next is when we are trying to find the power of me, we're using the force of me to find it. And when we're trying to find the power of the weight, we're using the force of the weight to find that.
Now I plugged all those formulas into Tracker, and let's see what graphs it comes up with. This is the force of the weight graph, the mass times acceleration in the y component. It seems to be at its maximum when I'm at the very bottom of the squat. That's when the most force is acting on the weight. That's probably because the acceleration is very high right there at the bottom. This is my force, that the force of the weight added to the mass times the gravitational constant. It also seems to be at its maximum point at the bottom of the squat. And this graph is the power acting on the weight, the force of the weight multiplied by the velocity in the y component. And it seems to be at its maximum right there towards the very top of the squat. And finally, my power. This is the really cool graph. This actually does match my human experience. I felt the most exerted when I was leaving the bottom of my squat. And that's what the graph is actually showing. These are all at the right after I reach the bottom of the squat and I start exerting the most amount of power when I'm trying to get that weight back to the top. So we got some pretty cool results this week. We got to use the other things that we learned from the previous week this week, like velocity, acceleration, and that Newton's force times mass times acceleration. With all of those, we were able to plug it into a computer system and find when I produce the most power. And remember, at the very beginning of this video, we talked about power is what you feel. So power was what I felt when I was pushing that weight up. The weight felt the force. And if you look at the graphs, they show this relationship. And it's what is really cool and what I find very fascinating is the graph actually matches my human experience. Like what I said when we were looking at the graphs, I felt the most amount of power being exerted from my body right after I was leaving the bottom of the squat. So I was exerting the most power right after I left the bottom and I started pushing the weight up. And that's exactly what the graph showed in Tracker. It showed the peak power was right after I left the bottom of the squat and started heading upwards in the positive Y direction. So that's really cool to me. I hope you learned something new, and thank you for watching.